Okay, so in this video, I'm going to do two things. The first thing is going to do a little bit more distribution, and then I'm going to go a little bit more into multiplying different variables and what that looks like. So let's start with this problem right here. We need to first, before we start any problem, take all of our subtraction signs and turn them into plus negatives. Again, it's not technically necessary, but it's very helpful when we're starting out learning to do algebraic expressions. Please turn your subtraction signs into plus negatives wherever you see them. Now you see that there is this term right here, okay, and it needs to be distributed over everything that's in the parentheses. There's no multiplication symbol right here, but it is assumed that it is needing to be multiplied against the parentheses because whenever you see a variable touching either a number or parentheses, it means multiplication. So if you want to, you can always put in a little dot here so it's more obvious to you, but you can put it in even though it's not going to be there on the paper for you. So just so you know, it's like an implied little dot right there. Okay. The other thing that I see students do is they will, instead of distributing this across everything in the parentheses, what they will try to do incorrectly first is say, oh, let's try to add these two terms together. Because they read from left to right, and they say, oh, okay, well, I see this plus that. Let's do that first. No, do not do that first. That violates PEMDAS. PEMDAS says you need to do all the multiplication in your problem first before you do any addition. And so if you were to add these, you would be circumventing, you would be bypassing, you would be skipping the crucial step of doing this multiplication first. So multiplication before addition. Do not add these and then try to multiply. You will not get the correct answer. Okay, so now that we know that we need to distribute this term over both of these terms, what we will do is we'll just bring this down and not do anything to it. And then we'll start our distribution. Let's first distribute over the first term. So this is going to be negative 4a times 2a to the third. Okay, so why don't I just write this? It'll be negative 4a. If you want to put in the little dots for multiplication, feel free to, but again, you don't have to because it's implied. So negative 4 times a times 2 times a cubed. Okay, we can do more with that, but let's just leave it for a second right there. Plus, you have to honor whatever whatever addition or subtraction is right here. So here's addition. And then you need to distribute this term over that second term. So again, that's negative 4 times a times negative 2. Oh, I'm sorry. This is good. You may have been thinking, what happened to this 3 in the bottom? I forgot about it. That's what happened. So it's important to go back and check your work. Even math teachers do that. So we multiplied the numerators. You could think of this as like being over 1. And then you need to multiply the denominators. Okay, can't forget that. So that'll be 3 in the denominator there. Okay, likewise, we multiplied our numerators. Awesome. Now we need to multiply our denominators. 3 times 5 is 15. Okay, so this is a really good first step of what we've got. Now we need to start simplifying a little bit. So let's look at this. Negative 4 is a coefficient of a. 2 is a coefficient of a cubed. You can multiply coefficients together. So because all of these are being multiplied. If you want to put a dot between every single number and variable, go for it. I mean, that's fine too. All of these are being multiplied. So negative 4 times 2 is negative 8. So actually, yeah, I do have enough room, so I'll write it down here. Please show your work as best you can It's a little, I might need to erase because I only have so much space on the video, but please always bring it down. So it's 3a over 10, just bring that down. This becomes negative 8. And then here, a times a cubed. What would that be? A times a cubed. Okay, so that's why I want to do a little bit extra after this problem. A times a cubed. Okay, so think of this. It's a times triple A. Okay, so now how many a's are being multiplied against each other? 4. So it's a to the 4th. Okay, so a times a cubed is a to the 4th. You may, in the back of your mind, be thinking, wait a second, these are unlike terms. I shouldn't be able to do that. You cannot add or subtract unlike terms, okay? You cannot add or subtract unlike terms, meaning you cannot combine unlike terms using addition or subtraction. So when we say you can't combine unlike terms, we're talking about you can't add or subtract them, but you can multiply them. You can absolutely multiply them. So a times a cubed is a to the 4th. So that's totally fine because it's multiplication. So it's a to the 4th, and it's all over 3, plus, okay, this is negative 4 times negative 2. Again, that's it's going to be a positive 8 here because it's negative times negative. Here we had a negative times a positive, but here's negative, negative, so it's a positive 8. And just 8, all over 15. Okay, so now what we have are two like terms. This is a like term because it has an A. This is a like term because this has an A. This is not a like term because it's a to the 4th. So while you can combine these two through addition, you cannot combine this through addition because it's a to the 4th. So let's add these two together. Well, that's a bummer. They have different denominators. You're going to have to make common denominators, okay? So the common denominator between 10 and 15, the least common one that I can think of is 30, okay? So this is 30. It's still on. Good. 3 times 10 is 30, so 3 times 3a is 9a, plus, and then 15 times 2 is 30, so 8a times 2 is 16a, plus negative 8a to the 4th, all over 3. Okay, so now this I can add together because they have like terms as well as like denominators. So 9a plus 16a, so that's 25a, because 9 plus 16 is 25, so it's 25a over 30. And we don't add the denominators, you just keep the denominator, just like whenever you're adding fractions. So it's going to be 25a over 30. Now, you can actually reduce this because 5 goes into both 25 and 30. So let's reduce that now. 5 goes into 25 5 times. 5 goes into 30 6 times. So that's 5/6 a plus negative 8a to the 4th over 3. Again, we cannot combine these two because this is a to the 4th and that's a. So this is our final answer. Okay? Totally fine to have that as a final answer. There are a lot of other ways that you can represent this. This is a perfectly great way to represent it. Another way to represent this is, remember when we had a subtraction signs and we turned them into plus negatives? You can always turn a plus negative and revert it back into a subtraction sign. So this is fine. If you want to revert it, these two, so it's just subtraction, that's also totally fine. Also totally fine, you could do that. Yeah, you could switch these around if you wanted to. So think of it as like, back to this plus negative. If you wanted to put, and I think it's still going to be just on the video here, if you want to swap these around, that's fine, as long as this negative travels with this term right here, okay? So make sure that this negative travels with the term. That's the beauty of having this plus negative, because it makes it so clear that this negativeness travels with this term, okay? So I've used this analogy before, like on the Peanuts cartoon, where you have Charlie Brown, and sometimes there's that cloud over his head that's raining, and it follows him wherever he goes. That's that negativity of that cloud. That follows this term everywhere it goes, just like that rain cloud. Okay, it's stuck with it. So if it is going to be rearranged, that's fine. You got to take it with it. Hopefully this is still in the video. Yes, it is. And then I can swap them, and that's a positive 5a over 6. So that's another way that you could represent this. Okay, so there are lots of ways to represent your answers, and they're all fine, all right? So I just want to go over one more thing. So that's this problem here. Okay, I just want to go over multiplying variables. Again, we've hammered into you that you cannot combine like terms, and that's absolutely true. You cannot combine x plus y. I mean, that's as far as you can go. Unless you know what x and y are, like their values. You know, if I told you that x was 2 and y was 3, then you could combine them and make it 5. But you don't know right now what these values are, so they're unlike terms, they're frozen. You can't do anything more to that. Same with x plus x squared. You can't combine these any further than they already are, okay? Because x squared is a different term than x. X squared is just as different as like a y, okay? Why is that? Because this is x plus x times x. You need to multiply these two x's first. Because of PEMDAS, you do multiplication before addition. So you need to multiply these first before you can add them. But since you don't know what the value of x is, it could be anything, it's an unknown, that's why it's x. Since we can't multiply these anymore, it's frozen in time. It's like stuck in the mud. Our process is stuck in the mud. There's nothing more that we can do. Because x squared needs to come up with some value for it before you can add it to anything else. Since we don't know what the value of x squared is, we cannot then add it to x, because we would then be bypassing our multiplication step in PEMDAS. It would violate PEMDAS. Okay? So that's why you cannot combine these. They're different, unlike terms. Okay? Here's the thing. When you have unlike terms, that addition and subtraction that you can't do with unlike terms, you can do with multiplication or division. Okay, you can do it for these operations. Okay, let me show you. Just like we did in the last example, a times a cubed is a to the 4th. Okay, so a times a cubed, these are different terms, but you can multiply. If there's a multiplication symbol, you can do that. Because look at that, it's a times, and this is triple a. Again, I might not put a dot between all of them, but if you want to think of them as having dots in between, that's totally fine. So this is a to the 4th. Okay, this is the 4 is called an exponent, and the a is called the base. The large number, it's like the base of a lamp. It's at the bottom, okay? And this exponent tells the base, in this case a, how many times a needs to get multiplied against a, okay? So a to the 5th, for instance, so if this was a squared and this was a cubed, these are different terms. You could not add them. If you try to add them, this is as far as you can get. Okay, this is as far as you can get with adding, but not with multiplication. With multiplication, you can go further, because this is a times. See, we're just multiplying the whole way through. I mean, these are getting multiplied, and then they're multiplied against each other. So it's just multiplication going on. So here's double A, and here's triple A. All right, sounds like different baseball teams. Okay, so now 1, 2, 3, 4, 5. We have A being multiplied against itself 5 times. Okay, so it's totally fine to multiply unlike terms together. Okay, totally fine. By the way, did you see a pattern? Did you see a pattern? When you're multiplying a's and a's together with exponents, you see that you just add the exponents? It's a rule, actually. So if you add a to the 12th times a to the 17th, okay, I'm not going to write 12 a's and another 17 a's. But if I wrote 12 a's and then another 17 a's all multiplied against each other, what do you think? How many a's do you think would be multiplied? You add 12 and 17, you get 29. Okay, so that's just a quick way to do those. Let's talk about when you have not only unlike terms, but unlike